All right, starting with this one. How would I determine, it says, what is the scale factor of the dilation from the inside one to the outside one? Figure out the points and see what you multiply by. Well, this point is like 0.2 and this one is 0.4. So what do I do? Multiply by 2. So then that would be my answer. All right. All right. They will give you stuff like this where you've got to write out what your process is. This one says a sandcastle mold is in the shape of a cylinder with a diameter of 6 inches and a height of 8. To the nearest cubic inch, how much sand will fit in the sandcastle mold? Explain how you determine the answer. In your explanation, use the word pi instead of the symbol for pi. Write your answer on the line. So what you would do is say, if it's asking for how much will fit in it, it's talking about volume. So you'd say, I would find the volume of this by saying this times this times this. Now they give me diameter. Do I use diameter? What do I use?
Width.
Radius. So I would have to say, I'm going to use a radius of 3 and a height of 8. I would find the volume of the cylinder doing that. And then make sure if it says write the word pi, then you write the word pi in there. It's just explaining the process you would do. It's not what I want. All right, on this, on the proofs, we didn't do the proofs enough. So all you can do on the proofs is write out the stuff that you know is the same. So like this says, prove they bisect each other. I would have to prove, I would say that these are the same because diagonals bisect. And these are the same because diagonals bisect. That kind of stuff. Does that make sense? So just say the stuff that you can say is congruent to each other, and then I know that these sides are the same because it says it's a parallelogram. So you'd have to go through it like that. Just come up with the stuff that you know is the same. All right, make sure we understand what a line segment, what an angle, circle, parallel, perpendicular, all that stuff. Remember on transformations is when we slide it. A reflection is when it flips. Rotation is when it turns. They're going to ask you some stuff like, what is the transformation? Like on this first one right here. What is the transformation? Which one is the original and which one is the image and which one is the pre-image?
The one without the palm.
All right, so my image is this one, and it's moving to this one. So which way did it go?
To the right.
To the right 2, so that's why they did x plus 2, because it went right 2. If it goes up or down, where does that go? Where does it go in here? With the y. So if it goes up, I would say y plus something. If it goes down, I would say y minus something. And over here, it did what? It stretched out and got bigger. So then you would see how much bigger it got. In this case, it was a factor of 2. You multiply the x number by 2 each time. All right, they're going to ask you about how does this one get to that one? Well, how would the 1 get to 2? What would I need to do?
Reflect.
Just reflect. Or, yeah, like this one, same deal. You follow the letters, so the A has to match the E because of the order they wrote it. So the only way that A could get over here would be what?
Reflect.
Reflect. Because could I do this right here and just slide it across?
No.
Not for this to work. If they didn't have the order of the letters like that, then yeah. If it was the A matching the F, sure, I could slide it and be a translation. But because they've got the A matching the E, then no, it won't. It's got to be a reflection. All right, so what would I do on this one right here? X minus 3 and y plus 1. What would I do?
Just go down.
What is the minus 3 tell me
Go
to
to
do?
the left.
yeah, go to
Left 3,
Up one.
up 1. So I would move every point left 3, up 1. If I reflect across the x-axis, you find the x-axis and see how far away each point is. So this point right here is on it, that stays. This point is 2 spaces up, so I go 2 spaces down. This point is 1 space up, 1 space down, and then I just reflect. How do I reflect across y equals x? That was on the test the other day that we didn't get. Switch the x and the y. Good. I'm glad we remember that. Switch the x and the y. So find all of these points and then switch the x and the y and it'll be on the other side. Alright? Y equals negative x. Switch the x and the y. Change the signs.
Mahia and Tanis Brooks report to Miss Bell. Jose and Tanis report to Miss Bell.
Again, there's all the translations of what they were talking about on those. How would this one right here, this first one right here, 2A, what did we do right there?
Rotate.
We rotated it, how many?
2.
How many degrees? 90. More reflections, rotations. All right, this right here, we didn't specifically talk about it this way, but it's real easy to figure out. If it talks about rotating about the origin, what it's going to say is going to be rotate or something about itself. Get the image back on itself. In other words, how can I turn it and it still look the same? What you do is this. You figure out how many angles you can make with the, each vertex. So see right here and right here, there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. Well, how many degrees do I have total? 360 divided by 6 means 60 would work. Does that make sense? Just figure out how many angles you can make with each vertex, and then those would work. So if it's 60, any multiple of 60 would work. If it's 120, any multiple of 120 would work. So a pentagon, how many angles can I make?
5.
5. There's 1, 2, 3, 4, 5. So what would I do with that 5?
Divided by
360 divided by 5. What is that? Anything right now? 72. So every 72 degrees would work. All right. That's just more of the reflection and rotation stuff. What you got to do on these is read what it's talking about on the choices and see where it would wind up if you did what they talked about. So like on this one, if I reflected across x equals -1, well, that would be here, and it would be turned this way. And translate 1 unit down. Is this going 1 unit down to get here? No, so I know that's not going to work. So you just follow what it says. Reflect across that and then translate 5 down. If I reflect it, it comes over here, and then is that 5 units down, start counting, and then you'll see what your answer is. There's a bunch of this stuff right here, similarity and congruence and all this stuff. How do we find the center of a dilation? Anybody remember? The center of the dilation. I don't know if this is what it's asking for here. But what you would do is say, well, A and A prime, I'm going to draw a line. And B and B prime, I'm going to draw a line. And C and C prime, I'm going to draw a line. And see where they all hit. 0, 0, that would be the center of the dilation. So that was asking you'd have to draw it out and then, yeah. So if I draw A prime is there, C prime is there, B prime is there, they all hit at 0, 0. Will it always be 0, 0? Absolutely not. Alright, see, what does this one say? Line segment is 5 inches long, is dilated to form with a scale factor of 0.6. Alright, if it tells me my first one, it said the scale factor is 0.6, is it getting bigger or smaller?
Smaller.
Smaller. So I would say 5 times 0.6, and that would give me my new length. So 5 times 0.6 would be the 3 that they're talking about. Does that have? What's the center of the dilation on this one? See, I did that. That's not a good line. There's that one. That one. So whatever that point is right there. 3, 2 or something like that. 4, 2. How do we determine the scale factor? Do the points, and then, like in this one, it tells me it's half as big. Oh, this is what this is talking about. Which one of these statements down here would work for that? How do I determine that? How do I determine it?
You get a point, you get a point.
AB goes over A prime, B prime. Does that make sense that B prime, C prime is going to be over BC? It's not the right order.
B.
AB over A prime, B prime, BC over B prime, C prime. There's my answer. What's wrong with the C? It's got the DF in there. That doesn't match anything. And this one, you got the DF, doesn't match anything. Just find the one that it goes in the same order. Again, here's finding the center. All I would do is connect the points. Now, it says PQ is a result of the dilation of XY. So which ones match up? PQ and XY. It doesn't have the primes for me to go by. How do I know which ones match up? The P comes first, the X comes first. So those are together. And then the Y and the Q. So then wherever that would hit. All right, here's where they're going to give you a proof and you've got to fill in the missing part. You just got to look and see what they've got and see which one would match it. There's one that's missing. Well, I thought they had one missing in there. All right, in the past they've done a bunch of these right here. I say a bunch. It's been on each test each time. A is 50, B is 100. It says, what is angle Z over here? Well, how am I going to find that? It says these two things are similar. What does that mean for angles? Angles is going to be the same. So if this one's 50, that one's 50. If B is 100, then Y is 100. So then how would I find Z? Add them up and?
40.
Well, what does the whole thing of a triangle have to be? 180. So if this is 100 and this is 50, that's 150. 180 minus 150 leaves 30. If they're similar, the angles match. We've got to get that. If they're similar, the angles match. This rule right here, it says find EG, GE. X over 3, 6 over 4, cross multiply and divide. All right, here's one I was talking about. They're asking for this step right here. It says HGK is equal to IHJ and IKJ is equal to that. Why would those be the same? What's the rule? These are parallel lines. What kind of angles were those? What kind of lines are they? Nobody can tell me. We're gonna be in trouble.
Corresponding.
Corresponding. So the reason that these are the same is because they're corresponding angles. We should, regardless of that being approved, you should be able to tell me those are corresponding angles. And that's all you'd have to do to get the answer. How would I know if these are congruent?
Point. And
Are the sides the same length? So if the sides are the same length, then what rule works? If the sides are the same, what rule works?
Oh.
If the sides are the same length as side. This one has angles in there. If this is the same as this and that is the same as that, what rule is that? Side angle side. So just look and see what you're given. Remember, if we're doing 90 degrees clockwise, we're going to switch them and change the X. If it's 90 degrees counterclockwise, we're switching and changing the Y. If it's 180, what are we doing?
Changing them both.
Switching the X and the Y.
Man, I'm so tired.
What? What did I just say?
About the 180,
What did I say?
you changed this, and you swap.
Switch the X and the Y. Isn't that what you said?
No,
He said,
said change both of them.
That's right. You change the X and the Y. You were right. I was wrong. Change the X and the Y. What rule could I use right here to say that these are the same? Now, y'all, if we miss these, now we're in trouble.
angle side.
Angle side, because there going to be some of those. Those should be easy. We get those and move on. What about these? It tells me DE is equal to JI and angle D is equal to angle J.
DH
It's asking me what else do I need to know?
and JL.
That,
If I know that this little piece is equal to this little piece, is that going to be enough?
no.
Yeah.
Why?
Because on the side,
Got
angle
this on
side.
side.
Because this part is the same in both of them. So I know that from D to F is the same as J to H. If these two little pieces are the same, that's the same in both, so then it would work if that little piece worked. So that was right. Isn't that what we said? Yeah. Here's that one that we did the other day. If the angles, how do you know the angles of a triangle are 180? Say that A is the same as this XBA and C is the same as YBC. And then those three at the top make 180 degrees. Do substitution. What did I tell y'all about this last step right here?
If
You said if them two.
that
If the next to last step says triangles are congruent, and then it says two pieces are the same, it's automatically going to be that CPCTC. If you have a triangle being congruent to the next to last step, and then something, whether this is sides or angles, doesn't matter for the last step. All right, so look at this. This we should be able to get even not doing a whole bunch of proofs. What is it that's saying on step 6?
ABC.
Triangles are congruent. So all I've got to do is go back up here and see what they wrote in. AD is equal to BD, so I'm going to mark that. CD is equal to CD. a right angle, and a right angle.
Side and side.
So then I got side angle side. All you got to do is look and see what they did and then fill in the missing part. All right, look at this right here. It's written out like a paragraph. What is the next to last thing they said? They said triangles are congruent by side angle side. Then it says angle S is congruent to angle U. This piece is congruent to this piece. CP, CTC. All right, so it doesn't matter if it's in the two columns or if it's a paragraph. If the next to last step says triangles and then pieces, then you know you got that. All of the construction stuff, what we were talking about earlier, all of those videos are up. You need to watch those. It's just going to be a matter of you being able to memorize the steps on the constructions. Come on, get this on. All right, the quadrilateral stuff we hadn't talked about in a long time. It says, how do I know when a parallelogram is a rectangle? Rectangle has to have what of these things right here?
That's it.
Does that make it a rectangle? That makes it a parallelogram. If the diagonals are congruent, that makes it a rectangle. Which one have diagonals that are perpendicular? Oof. A long time ago, coach. Which quadrilaterals have diagonals that are perpendicular?
Oh.
Square,
Doing like a rhombus?
rhombus, one more.
Crap.
No. Kite. Square, rhombus, and kite have diagonals that are perpendicular. How do I know if it's a parallelogram? Which of these things would work? If it shows me like this first one says AC and BD are the same, those are the diagonals. If the diagonals are the same, does that make it a parallelogram? No, that makes it a rectangle. Go through each one. And then B, slope formula so that AB are perpendicular. AB and CD are perpendicular. Is AB and CD perpendicular? No, they don't even touch each other. They're parallel. Use the slope formula to show that AB and CD have the same slope and AD and BC have the same slope. That would be my answer, because if this is the same slope as that, top and bottom, and the left and right, then you got parallel lines, then it's a parallelogram. Again, on the construction stuff, you just got to watch those videos. The first step on bisecting an angle would be to put your point at Y and draw the arc going across. Same deal, just we got to remember the steps. Sine, cosine, and tangent are on the formula sheet. You do not have to remember them. Any of these problems we should be able to get now. If it's sine, cosine, and tangent, they give you the formula. Again, it's basing off of the angle, that little theta. Why is this one called adjacent to theta?
It's so close.
Because it's close to it. Why is this one opposite from theta?
Across from
It's across from it. And then that one is always hypotenuse because it's across from the right.
Like a question, like if you not on that,
Oh.
just about the test. If you're passing this class with like above an 8, you
All right. How would I find the ratio right here, the scale factor? How do I find scale factor?
get points.
If it gives me all the sides, small, small, middle, middle, big, big, see if they match up. So 5 over 10 would be 1/2, 3 over 6 is 1/2, 4 over 8 is 1/2. My scale factor would be 1/2. Which one corresponds to angle B? Well, angle B is up here, angle E is up there. So we should be able to do all that stuff right there pretty easily, I think. All right, again, this right here they're going to give you this almost every time. It's already going to be done for you. All you got to do is figure out what to do, what rule would work. Is that sine, cosine, or tangent?
Sine. No, yes.
What side is that?
Opposite.
Opposite. What side is
Oh,
that?
that's tangent.
Adjacent. Opposite and adjacent is tangent. So I know I'm going to be using tangent. Now, this stuff right here, they give you that. You really don't need it because all you got to do is work it out. Just type it in the calculator. Remember, tangent is opposite over adjacent. If the number's in the bottom, what do I do?
Multiply.
Cross multiply. So I'll multiply 75 tangent 32. If the number's in the top, you divide. Like here, they're giving me the drawing, so it's already done for me. This would be opposite hypotenuse, so that is sine. Type it in. Here's the numbers on top, so what am I going to do? Divide, get my answer. If they ask for something like this, what is the measure of angle C? How do I find the measure? What am I going to do on the calculator?
The second and
Second and whatever rule. So in this case, I could do any of them. So you can do inverse sine and do 5 over 13, or inverse cosine, do 12 over 13, inverse tangent. Any of those would work for that one, but make sure you do inverse if you're looking for the angle. All right, here's the one we looked at the other day. It says A is 5 over 13 for cosine. That would be 5 and 13. What do I need to do over here? I would have to find the x. How would I find x? Do Pythagorean theorem. Wind up with x being 12. It says, actually in this case we didn't even need to do anything. It says, what is the value of sine b? What do I know about sine of b and cosine of a?
They just swap.
They don't swap, they're the same. The cosine of one is equal to the sine of the other one. So all that stuff we did with the 12, we didn't even have to do. I thought it was asking for sine of a. Sine of one, cosine of the other, they have to match. So in this, what is cosine of A? Oh my God, if they give us something like this, we should be drooling over that. Cosine of A.
12.
12, 15.
12.
Cosine of A.
Oh.
Cosine is
9 over 15.
adjacent 9 over hypotenuse 15. Do you see 9 over 15 as a choice?
No, so do we
Type it in the calculator and simplify it.
A.
If tangent is equal to 1, just remember this right here. Remember this one problem because I can almost guarantee it's going to be on. If the tangent is 1, that means sine is equal to cosine. Everybody hear me on that?
What?
If tangent is equal to 1, that means sine is equal to cosine. Alright? So just remember that and you'll get one. Here, same deal. Look, they're not even asking us to solve it. It's come up with the rule that would work for this. So all I've got to do is figure out which rule would work. What is it? Sine, cosine, or tangent?
Sine.
Sine of 75 is equal to what over what? Because it's got two choices.
X over 12.
It would have to be x over 12 because where does the hypotenuse always go?
On the bottom.
Hypotenuse is always in the bottom. Same deal. You're asking what rule is it? Not how to solve it, just which rule is going to work. So for this, where does that 54 wind up though? I don't use
at
it.
the bottom. Down here.
I can't use it outside the triangle. It's got to be inside the triangle. So make sure you put it down there and then work it with the triangle inside the triangle. So if it's down here in this bottom corner, that would be sine. All right, where are my problems? Come on. Alright, on circles, it tells me there's a diameter. APC is 100 degrees. So this one right there is 100. What would angle BPC, how much is this one going to be? Come on, y'all, we still got a few minutes.
8.
If the first one is 100, how much is that one?
100. No, 80.
80 because it makes a line. Angle BAC. BAC, how much is that? We just said that this was 100, right? And that was 80. So how much is this out here? No. What kind of angle is the 80?
80.
Central matches the outside. So if this is 80 on the outside, how much is this inscribed angle in here?
40.
That one's going to be 40. How much is AC right here?
100.
It's got to match the inside for the central. All right, so it says that AF is equal to 8, EF is equal to 6, BF is equal to 4, and EG is equal to 8. How would I find this little piece right here?
That would be,
I'm going to call it X right there.
yeah.
8 times X, 6 times 4. The two pieces of the inside multiply and equal to two pieces on that. And then it says find GD right here. Ooh, let's call that Y. What is the rule for that one? Square the tangent one, and then you say outside times the whole thing. And then you'd have to work that out from there.
Wait, never mind.
Good? All right, we'll have to stop there. All right, so here, if it tells me this point, I'm supposed to find this angle. It says AB is tangent to circle at point B, AC is tangent. What is the measure of that angle? What do I know about this right here?
The same.
If it's tangent, it's got to make a right angle. This 48 means this is 96, which means this is 96. So now, if I look at this, there's a 90, there's a 90, there's a 96. I'm looking for that one up there. You would have to add it up and make it equal 180. So if this is 6 above 90, it's going to be 6 below 90. All right, if they give us this right here, we should be good. It says, what is ABC? What is this angle in this corner? How much is this out here?
6.
If we are finding the area, that's what it's called, or arc length, excuse me, we're going to do degree over 360 times 2 pi r. Why are we doing 2 pi r? That's circumference. That's the distance around the circle. So if it's arc length, I do degree over 360 times 2 pi r. If it's area, I do degree over 360 times pi r squared. Why is it pi r squared? Why do I do pi r squared? What's the area of a circle? Y'all.
Isn't it 360?
Pi squared. Area of a circle is pi squared. So when it's talking about area of a sector, I've still got to do the pi squared part. All right, what would the area of this sector be? Well, I'm going to do degree over 360 times pi r squared. What's the degree in this problem? 50. It tells me if x equals 50, that means this is 50. So I'd say 50 over 360 times pi 8 squared. That would be my area of that sector. Now, look at the way they did the answer right there. What did they do? 80 pi over 9. What kind of answer are they giving you? Exact. They're giving you the exact answer versus the decimal answer. So just look and see what they did, and that'll tell you how to answer the question. It's asking me for the length of that. Degree over 360 times 2 pi r. Why am I doing 2 pi r? Because it said length. So I would say 145 over 360 times 2 pi 12. Again, what kind of answers are they giving me? The exact. So all I'm going to do is the number stuff and then find that number, put pi behind it, and you'll have your answer. All right, it says, what is the area of the shaded part? So what would I need to do? What's my degree? It is not 75.
75 minus 360.
Do 360 minus 75 first. That would be 285. So there's the number that I need to use. Why do I use the 285? It's asking me for the shaded part. The shaded part has that big angle. So then I would say 285 over 360 times pi r squared, because it's talking about area. All right. It says, what is the length of the outer edge of the wheel between two spikes? In other words, how far is that right there? How many degrees is it in here? How do I figure that out?
8 divided by 360.
8? 10, ain't it? So I'll do 360 divided by 10 and get 36 for each one of these. It says the diameter is 18. So I'm going to do 36 over 360 times 2 pi r, since it's talking about length. 2 pi 18, right? Wrong. Why do I have to do 2 pi 9?
Because you need the radius.
I don't need the diameter, I need the radius. All right, volume, they're going to give you the formulas. All you got to do is plug them in. Now remember, when they say capital B, they're talking about the area of the base. Well, the base is a rectangle, so that's length times width. If it's here, that's a circle, so that's pi r squared. Here's something we need to make sure we understand. Where did it go? Which one of these has more volume? They're the same width for the circle, they're the same height, but one of them slanted.
The one
The slant.
is not slanted.
They're exactly the same. Think of it this way. If you had a stack of quarters and I stacked them up 10 high, they would look like this, right?
Yeah.
If I had a stack of 10 quarters and I slanted them, how many do I still have?
Yeah.
I've still got 10. They got the same volume standing straight up as they do tilted over to the side. So if they give you any question like this, which they have almost every test we've had, those are going to be the same. The volume is the same. It doesn't matter if one's slanted or not. And what it's called is Cavalieri's principle. So here's what it looks like. I've got the same amount of quarters or whatever. So it's going to be the same. So in this case, I'd be looking for the one that says they're the same. Volume of a cylinder, we're going to plug that into the formula. Plug it into the formula. All right, we'll stop there. All right, so if I'm looking at this one, it says find the length of CD. How do I do length problems? Degree over 360 times 2 pi 12.
Yeah.
In this case, I would do the numbers and leave the pi part alone.
You can put that calculator.
Yep.
That's cool.
Actually, this is on the video.
Coach Reagan, were they like already